Okay, well, good morning, good afternoon, or good evening to all of you, wherever you are located around the world. My name is Colin Dennis, and on behalf of the British section of IFT, it's my great pleasure to welcome you all to this webinar on Is Food Structure the Key to Healthier Diets? One of our ambitions or aims within the British section of IFT is to promote the international exchange and sharing of scientific endeavor to advance the science of food and its application in the global food system. And I hope you agree today's event is a good example of doing that. We have two excellent internationally renowned speakers within their own scientific specialities. And in addressing today's topic, the first speaker, Professor Jeyakumar Henry, will focus on the interface between food technology and how that has played in and will play into the nutrition space, while Peter Burgess will provide a perspective from sensory science and the role that texture has in influencing food choice and energy intake. So quite two contrasting talks, but I hope you agree quite complementary in many ways in addressing this complex issue. During my career, I have had the pleasure of working with both Jeya and Peter, and I know that they are highly renowned in their respective fields. Our plan today is that each of Jeya and Peter will speak for about 25 minutes, so that hopefully at the end we've got at least 15 minutes for general discussion and questions. But during the presentations, please feel free to add any comments or questions in the chat, and we'll do our best to monitor those and then address the questions at the end. I'm just going to give a few words of introduction for each of the two speakers, but I encourage you, they've both got quite long CVs, so I encourage you to go to their LinkedIn profiles to get more information. So firstly, Professor Henry, after 12 years as Professor of Food and Nutrition at Oxford Brookes University, Jeya moved to Singapore to head up the Clinical Nutrition Research Center within A-STAR. And as you see from the slide, he's now also Deputy Executive Director of the Singapore Institute of Food and Biotechnology Innovation. While in the UK, Jeya served on the board of the Food Standards Agency and was awarded in 2010 the BNF Prize for his outstanding contribution to nutrition. And then more recently, the IFT Kellogg International Award was given to Jeya for his global contribution of integrating food science and nutrition. So hopefully you agree we've no better person to open today's session. So Jeya, please, over to you.
Thank you very much, Colin. Lovely to see you as well, as always. Let me also echo a big thank you to the IFT British section and the IFST for really organizing this event. And a special shout out to you, Colin, who's been a colleague and a friend for nearly 3 decades, and most of all for initiating this webinar. So welcome to all of you from all parts of the world. Although I am talking to you from Singapore, my heart and spirit is with all of you from wherever you are in whatever part of the world. And also a big shout out to all my friends and colleagues in Britain, where I spent nearly 3 decades, as Colin has pointed out. So ladies and gentlemen, this afternoon or this evening, my presentation is entitled Contribution of Food Technology to Public Health and Nutrition. So there are 3 elements to this talk. First, related to food technology, the second related to public health, and the third with nutrition. And that is what we're trying to triangulate in the next few minutes. Next slide, please. So let's pose a rhetorical question. Can we trace the origins of modern food technology? And I want to posit, I hope you'll agree with me, that a seminal work by this French chemist, Nicolas Appert, in 1810, changed for the first time the complete paradigm of food technology. Why was it so? because he was the first to idealize and conceptualize the concept that we call appetization, colloquially known as canning, because it allowed people for the first time to preserve food and therefore remove the seasonality of food and allow people to eat food anytime, any place, and in any location. So I think this was a revolution, and I want to posit that we can take as a preamble 1810 as a landmark event for the beginning of food technology. So that may be debated, but let's take that as a granted paradigm. Next slide, please. In contrast, nutrition really came into its fold about 100 years later, when a Dutch chemist called Eichmann, working in the current day Indonesia, which was called Batavia, who discovered that chickens that he was rearing in his experimental station had a disease that we now call beriberi, due to the deficiency of a compound called thiamine that was lacking in polished rice. Subsequently, in 1912, a Polish-British scientist called Casimir Funk, who was working in the Lister laboratories in London, coined the word vitamin in 1912. And as you all know, Eichmann and Hopkins in Cambridge got the Nobel Prize in Physiology for the discovery of vitamins. So you could argue that there was a spatial difference between the modern technological revolution of food technology, which was around about 1810, and the advent and the discovery of modern nutrition, which happened at about 1912. So two important points. There was a spatial difference about 100 years between modern food technology and nutrition, but the important point to remind ourselves that food technology and nutrition are just 100-200 years old. So in the broad tapestry of modern and ancient history, it's a blink of an eye. And I want to argue that in that short period of time, it has had a profound effect on our public health and global paradigm of health and nutrition. Next slide, please. And lastly, many of you know that the southern states of America were ravaged by pellagra, because these states were essentially living on corn, and corn that was not properly processed was devoid of niacin, and that gave to pellagra, which is a global pandemic, especially in parts of South and modern day North America. And as you can see, it was characterized by dementia, diarrhea, skin lesions, and the fourth one was death. So therefore, deficiency of pellagra caused death as well. Next slide, please. And here you can see a remarkable synthesis of ideas. So if you recall, in the 1900s and until the 1950s, large swathes of people in North America, especially in the southern states and South America, were dying of pellagra by the deficiency of niacin. And you can see here that with the advent of fortification of corn, there was a precipitous decline in the incidence and prevalence of pellagra. Next slide, please. So I want to posit that food fortification is the first and best example of the matrimony between food technology and nutrition to provide public health. So if you recall, my talk title was Marrying Food Technology with Public Health and Nutrition. And this to me exemplifies the connection between food technology and nutrition in a way that still reverberates its importance in public health. Next slide, please. Similarly, as those of you know who have traveled all around the world, even places like Switzerland, who had endemic goiter, was eradicated by the fortification of iodine with salt. And many countries that surround Africa and in parts of Papua New Guinea and many other regions of Asia, still there are bouts and spouts of goiter, and these have been eradicated by the introduction of iodized salt. And you can see here a large range of foods that are fortified, and you'll be surprised to learn that most of us in the Western world get a large proportion of our micronutrients by eating breakfast cereals, margarine, and many other fortified drinks and beverages. So the point I'm making is that fortified foods still play a pivotal role in appeasing the nutritional needs, particularly the micronutrient needs of our population. Next slide, please. So I want to go back down into history and remind ourselves that for millions of years, our ancestors were hunter-gatherers. And then something happened about 10,000 years ago, where we started to domesticate plants around about the Mesopotamian region, the Central South American region. So these are the two epicenters that have been documented by archaeology, where we started to plant agronomic plants as human needs. And then around about 1800, which I commented a moment ago, was the introduction of food technology. So just to be mindful, our first food revolution happened about 10,000 years ago with the domestication of plants. Notice on the right side of the slides, these are data from real life hunter-gatherers of today, who are the snapshot of our past ancestry. Notice the number of plant species that they are consuming on a daily basis to meet their nutrition. Next slide, please. This is a sobering reminder how rapidly we as humans have gone down from the large taxonomic tapestry of plants that are available, 30,000 edible plants, 7,000 that are used by local consumers, down to 30 that provide 90% of our calories, and surprise, surprise, 3 staples, rice, wheat, and maize, provide 60% of the calories of all people living on Earth. Next slide, please. And of course, if you then add the tubers, so you have 6 staples: wheat, rice, corn, potato, cassava, and sweet potato, that really represent about 80% of the global consumption of staples. And therefore, it is quite remarkable that we are living principally on a monoculture. Next slide, please. So I want to remind ourselves that in the past, all the alchemists were keen to do was to transform base metals to gold. And I want to say that the modern food technologies is an alchemist that tries to transform the noble grasses, rather the noble gases, into a variety of foods. And you can see that if you took a humble staple like wheat, you can make over 2,000 different types of foods. So who could believe that a humble wheat gives rise to a noodle and a strudel, which are diametrically different in gustation, organoleptic properties, and nutrition. And I think the genius of food technology is this transformative ability that actually preserves nutrients and also makes the palatable experience that much better. So the second food revolution, I would posit, is the introduction of food technology. Next slide, please. But let us draw back some interesting lessons. Point number 1, moving from domestication of plants to the advent of food technology, we reduced our plant species considerably, which we have seen. We also were highly refining the food to get rid of the micronutrients. And also, as an obverse reaction, we expanded the food variety. It is quite amazing that a well-stocked British supermarket or a well-stocked North American supermarket will have 40,000 different foods that come from less than 30 different food systems that includes oils, nuts, legumes. So look at the revolution that's happened. But of course, food variety predisposes us to eat more, and also the advent of high glycemic index, which I'll talk about in a minute, and of course, the leaching out of vitamins and minerals. Next slide, please. So I want to remind ourselves what is the connection between food technology and nutrition is because one of the public health challenges that confronts us today, whether in Britain or in Asia or in Singapore, is type 2 diabetes. Type 2 diabetes is a dysregulation of your blood glucose, and you can see that for every diagnosed diabetic, that are 500 million in number, of which half live in Asia, there are 3 to 2 undiagnosed diabetics that become diabetics in the next few years. So we are talking about 1 billion people having diabetes or pre-diabetics in our modern contemporary society. So the question is, how can we make or prepare foods that are high glycemic index, with the red line, which inflects your blood glucose very rapidly and comes down rapidly to a low glycemic index food, which is your green line, which has got a subtle blunted blood glucose, which is good for your body, good for your pancreas, and reduces the risk of type 2 diabetes. So what I want to share with you is, next slide, please, an interesting observation made by a food chemist many, many years ago in Japan, and now widely executed by a German company called Benio. So you can see here, very interestingly, there is a sugar called isomaltulose, very similar to sugar, which has got a sucrose and a fructose molecule. But all that has happened is that the bonding is from a 1,2 glycosidic bond in sucrose to a 1,6 glycosidic bond. And that bond configurational change gives you some remarkable glucose responses. Next slide, please. So you can see some data from our own laboratory. The red line is a sucrose, goes up like Mount Everest and comes down. And look at the same disaccharide, which is isomaltose, gives this beautiful blood glucose response that is sharply different in millimolar difference between the sucrose and the isomaltulose. So reminding us that food chemists has allowed us to look at a whole range of sugar-like compounds that attenuates blood glucose in a way that is quite revolutionary. Next slide, please. So what we then did was we used these things that are common now, called continuous glucose monitors, that you can actually insert just below your skin, and it allows you to measure interstitial glucose up to 2 weeks, a remarkably clever machine. So what we did was we gave a group of subjects a high glycemic index food at dinner, lunch, and snack. And you can see all we did was, it was a crossover trial. On one occasion, we gave these dinner events with a drink made out of sucrose, and the following day, the same meal given with 30 grams of isomaltulose. And you can see by giving people the isomaltulose, you can dramatically reduce the blood response at supper, at lunch, at breakfast, and at snack. So what is quite fascinating, that a single drink that you consume with your normal diet can profoundly alter the glycemic response in a way that is beneficial to you in terms of public health. Next slide, please. So now I move on to saying, I think the biggest revolution that's going to come in the 21st century is to understand food structure through the lens of nutrition, because we know that food structure has been researched for many, many years through the kaleidoscope of rheology, textural changes, functional properties in terms of thickening, and all of that. Next slide, please. What we are asking, a rhetorical question, is that can we use food structural engineering to manipulate its novel ingredients or physical chemical properties to enhance health and sensory properties? And that's what I want to spend the next few minutes. And I want to posit that the next disruptive science in food science and technology is the understanding of food structure for human health. Next slide, please. So this is a slide that I borrowed from Jose Aguilera from Chile, and I have added to his graph these 4 revolutions that are going to happen in the next few years. First is understanding food structure for human health, development of food mimetics, which I'll talk about, real-time measurement of nutrient profiles. We simply do not know what is the nutrient deficiency that I have as I speak to you now. So what we can do is that we can now find ways to look at your nutrient profile and then look at ways of eating foods that will appease your nutrient requirements. And I want to also point out that there are 3 billion people today that are going hungry because of lack of food or a lack of micronutrients. So and I think there's a huge opportunity for us in the food technology fraternity to look at how do we make low cost, high nutrient value foods that we have not been looking at as a focal point of these vulnerable people that are 3 billion in number. Next slide, please. So here's what I'm going to talk about, a classical example of understanding food structure for human health. So some years ago, we observed that if you took 4 to 5 grams of ethyl cellulose and put it into a jar of oil and heated it to 150 degrees and cooled it, this liquid oil became a complete gel. So in other words, the oil, which has similar fatty acids as before, has formed itself into a gel. So there is a physical-chemical transformation. So we asked the question, what would the physical-chemical changes do to your physiology? Next slide, please. And much to our surprise, coconut oil has always been labeled as a highly lipidemic oil. So this is the coconut oil fed to you, and no surprise, it is a highly lipidemic oil, and so the blood lipids went up through the roof. But the same oil, remember, that's now in a gel form, shows hardly any lipidemic response. So it's completely blunted. So here's a fantastic example of how understanding structure of food is going to revolutionize the way in which we make food, not only for palatable reasons, but also for nutritional reasons. Next slide, please. So here's something else that I want to talk about, food memetics. Can Mother Nature teach us lessons that we can reverse engineer in the laboratory? So here's an example. You can see here that lentils have a very low glycemic response compared to rice and glucose and potato. And the question has to be, lentils, as you know, has about 25 to 35% starch. So what on earth is happening? Why is the glucose so blunted? It turns out that these starch molecules are surrounded or entrapped by a protein encasement or a hemicellulose encasement. So can we start making foods by reverse engineering carbohydrate moieties enveloped with a protein matrix or a cellulose matrix? And that is an area that I think is going to become quite a remarkable revolution in the next years to come. Next slide, please. So just to encapsulate, understanding food structure will allow us to design foods in a way that we have never done before. And of course, these products will be able to be marketed in the supermarket for improving health that has got all the gustatory properties and the sensory properties that you and I need before we accept and buy a food. Next slide, please. So I now want to come to the third food revolution, is the alternative protein as a case example. Because we remember the first revolution of the domestication of plants, and the second was the advent of food technology. And why do I call this the third food revolution? Next slide, please. Because alternative protein-based foods are made in a completely different way. No time in the annals of human history have we deconstructed the food source. So we took cassava, brought out the cassava flour as starch, took soybeans, isolated the protein, took coconuts and isolated the coconut oil, and then we reconstructed it. Reconstructing food has never ever happened in the annals of human history. And what are the implications? First and foremost, all the micronutrients are lost because they are isolated proteins. All the phytochemicals are lost because they've been taken out. And also, most importantly, the configurational changes, we simply do not know what are the structural changes in the protein or the lipids that we need to be cognizant when we make these things. So I want to throw up a point of concern that we in this business of food have to be looking at how can we regulate these foods in a way that we may not have done as systematically and rigorously as we should have. Next slide, please. So I know I've cantered through these things quite fast, but I hope I've convinced you that food technology has made a major contribution to the provision of safe foods and increased the food variety all over the world. No doubt about it. Food is becoming the new medicine. Just to remind ourselves, in the late 1970s, Sir Richard Dole, the famous epidemiologist from Oxford, said 70% of all chronic diseases have a direct or indirect effect on the diet that you consume. So therefore, the diet becomes an incredibly important receptacle for public health. And I believe that innovations in food technology will remain at the heart of developing food for the future. Food fortification has played a pivotal role in eradicating several micronutrient deficiencies worldwide and remains an important paradigm even in the 21st century. Next slide, please. Innovations in food technology, notably the understanding of food structure in human health, will enable us to develop new nutrient ingredients that will improve the stability, nutrition, and enhanced bioavailability. I think this is an area that we will need to focus in the years to come. Application of food technology will continue to play an important role in eradicating global undernutrition. I want to spend a minute on this just to go back to what I said. It is shameful that 3 billion people today in the 21st century are going hungry of either nutrients or micronutrients. And how can we as a global fraternity address this problem? Because I believe the greatest challenge today is how best we can feed the entire world rather than parts of the world. We are living at a unique time in human history, which major threats to our food and food security. We collectively, ladies and gentlemen, can become global leaders in the interface of food technology and human nutrition to solve food and health-related problems worldwide. Ladies and gentlemen, I want to end by saying we are really at a crossroad in human history where food security will shape our very survival. Those of us in the food technology, food science, and nutrition arena are really a privileged community because we can touch human lives wherever they are like no other district. Over the decades, Britain has played a pivotal role in providing training and scholarship to thousands of students worldwide, both in food science and nutrition. And I owe a debt of gratitude to all of you in Britain for making what I am. Finally, organizations such as IFT and IFST play a critical role in engaging nutritionists, as Colin pointed out, from all corners of the world. Long may this tradition continue. This, ladies and gentlemen, is what makes Britain Great Britain. And finally, last slide, please. I want to again acknowledge, look at Colin, 10 years ago when he was in Singapore with us, handsome as ever, young as ever. And last but not least, a big shout out to you, Colin, and also the British branch of the IFT and IFST. But most of all, also my students in the UK, in Singapore, and many parts of the world who have contributed profoundly to the growth of food science and nutrition globally. And thank you very much again for all your help and support. And this is my group in Singapore on the right side of the template. Thank you once again.
Thank you very much, Jaya, for a very enlightening and, as usual, very enthusiastic presentation. A great exemplar of a food scientist, food technologist, nutrition interface. So thank you very much for that. Can I just remind all the participants, if you'd like to make questions or make any comment, please add them to the chat while our next speaker's speaking, either to Jaya or to our next speaker, Peter Burgess. And I had the pleasure of working with Peter during my time at CampdenBRI, but initially training in economics, Peter really developed his career in consumer and market insights. And he joined us at CampdenBRI in 2003, and then assumed the head of Consumer and Sensory Science Department in 2005. So during his 19 years or so at CampdenBRI, he has led an expansion of the breadth and reach of the department, and has personally championed the development of consumer and sensory science methods in optimizing their impact in the application, or in their application, in product innovation and product success. So again, we've got an ideal speaker to now take us from the food technology arena, but really give us the most important aspect, and that is the sensory and consumer insights. So Peter, please, over to you.
Thank you very much, Colin, and hello to everyone joining the session today. It's really great to be invited to take part in this, and a lot of the comments I think that I'm going to sort of touch on over the next 20 minutes or so really kind of echo and build on the comments that were made by Professor Henry in the first session. So as you said, Colin, you know, these two talks are quite complementary, or looking at things from a slightly different lens. So what I was going to focus on really was, you know, from the sort of perspective of the Camden Sensory team, CampdenBRI Sensory team, who've really kind of engaged with the food and beverage industry in a broad way. Looking back, to me, there are two kind of broad innovation themes that seem to be emerging in relation to food choice and energy intake in particular. And I think the first of these really relates to eating experience and environment, and acknowledges really the significant impact that those factors, I think, have on food preference. And this is leading researchers in the consumer sensory science space to consider the consumer experience using kind of more immersive technologies, things such as virtual reality approaches, augmented reality approaches, to really collect more sort of what I call more contextualized data. And indeed, at Camden, we've just started at the beginning of this year. We sponsored a PhD student with Nottingham University and also the University of Adelaide to actually look at some of those areas. So that's a really exciting PhD project that's just started at the minute, and I'm looking forward to kind of seeing what's coming out of that session over due course. The second area in my mind is in terms of these innovation themes tend to be around, echoing what Professor Henry mentioned, the sort of how can we use sensory cues that can actually design products to help consumers make healthier choices, make those kind of choices easy for consumers. You know, how can we, for example, in the context of this particular talk, use textures to actually make people feel more full when consuming smaller portions without actually compromising their overall taste experience. And for today's session, and given the nature of the talk, that's the area I want to focus in on. But maybe the sort of I would say the immersive technique approaches and the application of things like augmented reality and AI could be a topic for a further meeting in due course. So next slide, please. So just stepping back a little bit, I mean, texture, I mean, as a food sensory property is really a key attribute for consumers to appraise foods in terms of food quality, in terms of freshness, in terms of acceptance, and obviously the rate and extent of food taste and odor substances released from the food matrix during consumption. So texture is really critical. And a lot of work that I've undertaken at Camden previously, and the team there consistently do, is really to think about texture in the context of food formulation, really about how to use texture to optimize consumer appeal of the product. But actually, if we consider texture in the context of oral processing behaviors, perhaps there are other things that we should be considering around texture that could contribute to healthy eating behaviors. So when I talk about oral processing, essentially this chart here shows the classic kind of oral processing model, if you like, and it's all about, you know, preparing food to be swallowed by reducing the food to the right particle size, the right level of lubrication, as reflected, as I say, in this particular model. And this model obviously has been around for a while. It was conceived very much to reflect changes to enable safe swallow of foods. But if we overlay additional information around oral processing behaviors such as bite size, chews per bite, and eating speed, perhaps this is a useful model also to conceive the impact of food texture on habitual eating behaviors. So for me, I think one of the key questions that I have in my mind from today's session and then putting this together is really, can food texture, through its impact on oral processing and specifically on eating speed, be used to guide the rate of calorie intake and mitigate potential risks associated with consuming high energy foods at a faster rate? Now, I have a confession to make here that a lot of this thinking was stimulated through a presentation that was given by Professor Kieran Ford, who actually used to work with Professor Henry over in Singapore. And that Professor Ford gave a presentation at the European Sensory Network meeting, that research group, and that really has stimulated, kickstarted the focus of that group, looking at texture and how we might use texture to improve healthy choices. So I'm going to be relying on a lot of the slides that Siren's put together that was presented at that ESN meeting a couple of years ago. So next slide, please. So, what's the evidence then? What's the evidence around eating rate and its association with energy intake and specifically obesity? Well, there's a whole raft of reports that have been published, and some of those are just cited in this slide here. But it's really interesting that I think that the sort of rate at which individuals consume a meal has been shown actually to be really consistent over time. And actually, obviously, this is in part influenced by their drive to eat and also by the textures and properties of the food they choose to consume. But looking through some of these papers, what's quite interesting, I think it's a paper that Professor Henry published, is that it's estimated that something like the genetic and biological factors are estimated to account for about 15% of the variations in eating rate. And it suggests to me that there's a lot of learned and environmental factors that are obviously going to be combining to influence rates of eating. So there's a real opportunity, I feel, at the individual level to tackle some of these. And a lot of those eating rate patterns are established at a very, very early age. And indeed, some of the large-scale studies that have been published also show that people who self-report to eat faster have a higher risk of obesity from those that are reporting to be slower eaters. So that's really, really kind of interesting. So I think, there's some emergence there, some pointers that there's opportunities to adjust eating rates, and a number of intervention studies that targeting eating rate could be an effective approach to actually changing behavior and body weight. So next slide, please. So this is, again, just an illustration of one of those studies where we're looking at the kind of eating rate of a test food. Sorry, go back to the previous slide, thank you. Eating rate of a test food, and that clearly was a significant predictor in energy take at a subsequent test meal. So some real kind of interesting relationships that have been established between test foods, food intake, and eating rate. And indeed, I think an earlier comment I read in some of the documentation was showing that basically reducing eating rate by about 20% has the potential impact to reduce average food intake by about 15%. So I think there are some strong pointers there for the food industry community to build on to take these concepts forward. So next slide, please. So yeah, there's a lot of activity that's been taking and building on some of that research, and some of these examples here have been focusing on targeting initiatives to target the person. So we have, for example, on the top left a slide, the EU Splendid project, which is all about targeting teenagers, young adults in terms of their eating behavior, linking technology to guidance on eating slowly and losing weight and feeling great is the strap line there. But again, quite a lot of initiatives on that space, which I thought was quite interesting. Through to the bottom right hand side there, which is the Smart Bite device, which has basically been introduced and linked to an app to actually try and help people eat slowly, through to even designing plates of slow eating rates in obese dogs, which is shown on the Fun Feeder slide on the left hand slide there. I'm not so sure about the jaw wiring approach as shown on the top right hand slide, but what I'm trying to show and illustrate here is actually there are quite a lot of initiatives in momentum, if you like, in developments that have been applied that really have been targeting behaviors at an individual level to reduce eating rate and energy intake. And does it work? If I just go to the next slide, please. Again, some really interesting publications coming here. And this particular example I've just illustrated here, looking at childhood obesity by retraining. And this is all very much helping young people to learn to eat again. And this was an interesting approach, looking at using a mandometer, which basically is a device that monitors eating speed and actually feeds that back to individuals and basically guides participants to eat either slower, really to follow the suggested eating speed rate in order to kind of compensate for eating too quickly. And this study particularly showed that over a 12-month period, amongst those people that went through the that trial versus the control group, BMI actually over that period actually dropped amongst that group. So some really interesting kind of outputs, I think, that suggest that slowing down eating rate does actually work in terms of BMI and its impact on BMI, should I say. So next slide, please. So a lot of the examples I've given so far have been focused very much on targeting what I would call the individual. This is now looking more about what can we do about texture to look at reducing eating rate and the energy intake. And as I mentioned, this study, particularly the example at the bottom there, demonstrated that a texture intervention resulted in a 15% reduction in calorie intake, but no reduction in meal liking or post-meal fullness. And I think, as I say, there's some real opportunities there to look at texture and apply texture to see what impact and build on some of these studies to see what impact we can have on energy intakes. And one study that I've noticed that was launched back in March of this year, March 2022, and this is a joint study with Wageningen University and UFIC, and it's called the Restructure Project, and that's all about developing and implementing innovative and evidence-based food design principles to moderate intake. So I think that's going to be a really interesting project to keep a watch on. As I say, that's just commenced in March of this year. So what I want to do now is just to move on to where we are in terms of the sensory community, and I think recognizing the growing interest of texture and its impact on healthful choices, and what we can do in the sensory world to perhaps get a better handle on how some of these attributes are being assessed by consumers. And so I wanted to talk a little bit about a project that's been completed again by the sensory team over at Camden that was published again earlier this year, which was looking at the characterization of food products using this what's called TCATA approach, which is a temporal check all that apply approach. And there are several methods around which monitor attributes over time during consumption. But we focused on this particular one because we found, certainly from some preliminary work, that it had real application amongst consumers, and we thought it had a real opportunity to understand the product from a consumer perspective in some detail. So, as I say, TCATA, or temporal check all that apply, it's a temporal method. It really captures the sensory characteristics of the product during consumption. And essentially what happens here is assessors are given basically a sort of edited, a curated list of attributes alongside a full description of those attributes, and they select and deselect those samples as they perceive them during the consumption process. It's based on a kata-based method, but it's an extension of that. So it's a really interesting approach. So next slide, please. So just to give you, I'm not going to go into the detail of the method. As I say, all of the information and the research is published in the document, which I just highlighted on the previous slide via the Camden sensory team. But in essence, what happens here is there's a fair degree of training with consumers to actually utilize this approach. And that's actually key. We practice with some dummy samples, so the process, the method is well understood. A lot of protocols set around number of bites, when to swallow, and how to select and deselect attributes as they're perceiving them. And again, emphasizing the point that the attributes that we're using really need to be curated, Normally they're defined by a trained sensory panel, but they've got to be really clearly defined. There is also the issue about making sure that the number of attributes used are limited to reflect the ability of consumers to actually give some, real response to the attributes that are shown. You're not over tiring some of the participants. So just to give you some examples of the outputs that you can get from this kind of work, could you jump to the next slide, please? So there are a number of different outputs, and I've just illustrated a couple here. Those on the left are what we call sample-specific curves, and in this study that I've used as an example, this is basically showing two chicken nugget samples, one that are plant-based, which is on the top left-hand side, another with standard chicken nugget on the bottom there. And again, what you can see is the various kind of attributes, the curves basically reflected on time and the portion of people perceiving those attributes during that consumption process. The chart on the right, the sample comparison curves, really just illustrates and makes it a bit clearer, I think, the differences between those two samples, those that are plant-based and those that are non-plant-based. And here you can see, for example, the crunchy attribute, which is the bottom dotted line towards the bottom of that chart, is much more pronounced amongst the chicken-based nugget than the plant-based chicken. So you can start to understand how those attributes build over time and how they kind of fade during that consumption process. So we get a better fix in terms of understanding the discriminate, how those samples are discriminating, not just based on liking or just not based on a static approach to the assessment. Can I jump to the next slide, please? There are other things that we can do with this data, this kind of rather busy slide, but what we importantly can do is link the outputs from the TCAT trajectories, which we've shown here, which basically maps how the attributes and the samples relate to each other over time, and then also link those things to acceptability or liking, or indeed other instrumental measures, which Professor Henry might have mentioned earlier. So there's a real scope, I think, to actually utilize this method, this approach, to better understand how we can understand how texture is impacting and being processed during the consumption process, and the impact it might have on people's choices. So just to summarize, looking at time, so next slide, please. Really, I think, oral processing behaviors in my mind, based on the work that we've done at Camden in this area, and has been demonstrated by other research groups, are modified, I think, in response to food texture, which you can slow and reduce the rate of an extensive energy intake, which I think is really, really interesting. I think I'd like to pick up the point that maybe Professor Henry mentioned, that the real challenge, I think, is to take these insights on texture in terms of eating rate and energy intake and actually build those into actionable food design principles, so that we can really promote healthier diets that maintain their appeal. And I think TCAT as a sensory method is a real place to use that to help our food science teams or food technology teams to better understand consumer perceptions and product acceptability. And so the last thing I'd like to focus in on is just to summarize in terms of where sensory fits. I think the role of sensory here is a real opportunity to link, if you like, nutrition focus, which obviously is focused very much on food composition, and food science, which is very much focused on processing and technology, and actually bridge those two areas together in order to kind of hopefully start to steer consumers towards more healthier food choices. So that was all I had for today. Thank you for listening, and yeah, thank you for your time.
Thank you very much, Peter, giving us that slightly different perspective on our subject today. And thank you to both speakers for keeping to their time slots. We now have ample time for questions and discussion. One question that did come up was, can the slides be downloaded anywhere? I think, Abigail, maybe the best thing is to contact each of the speakers directly on that one, although the British section will be having a recording of today's session made available to all that registered. So, but I think if you want specific slides, I would suggest you might contact Jeya and Peter. Yeah, we've also got a question here straight to the jugular, I suppose, straight to the marketplace. How does healthier food outcompete so-called junk food in the market? Bearing in mind the temptation and the commercial advertising that goes behind it. I mean, I think you've both highlighted there is a challenge, so it might be worth both of you just commenting about interest currently from industry in the sort of work that's being done. Jaya, maybe you could start, and then I'll ask Peter.
Yeah, thank you, Yang Yi. It's a very, very eloquent question. I think it's fair to say that many food companies have recognized that the consumer is demanding more and more healthy foods. But the paradox is that we need to make some of the healthy foods more palatable. So I think it's an oxymoron that by and large, healthy foods are usually not very appealing, and I'm being honest with you, and probably have much less desire for sensory acumen. So I think it's in early days, but the fact that the consumer wants to have both elements, tasty, delectable, palatable foods, but also nutritious, becomes as I mentioned, an oxymoron, but that oxymoron can be broken, I think, with the kind of a discussion we're having about understanding food structure, understanding how human sensory attributes that Peter talked about, and also the whole question of bioavailability. So I think your question is an important one. I have no clear answers for the moment, except to say that food companies are also addressing this issue because the heart of consumer interest is healthy but palatable food. And I think that's my real sort of response to your question. Thank you.
Peter, would you like to comment?
Yeah, I think from my point of view, one of the two areas in terms of moving forward with healthy choices and actually competing is on two fronts. As Jaya Henry, it's also about very much about acceptability and palatability. But in addition to that, I think there's a real focus on consumers looking for authentic, healthy foods. And I think there's a temptation, and without citing any particular brands or evidence, there's some evidence that some of the almost health washing of products, they're not really delivering on those healthy attributes, which I think consumers are looking for. So my real focus is for brands to focus on their authentic positioning and communication of those healthful aspects of their products. And the other second thing is about pricing and affordability. And I think there is again some evidence that some of the healthful options perhaps are more expensive for your typical consumer. And given where we are in terms of pressures on cost of living crisis and so on, I think that's something that we need to look at. So I think in addition to Jaya's comments, I think those are the areas about authenticity as well as affordability are really key.
Okay, thank you, Peter. Thank you, Jaya. This is an interesting question. I think Jaya also online with
Sure.
We were discussing earlier.
Sure.
Julie has asked, she's saying she's a nutrition scientist and very interested in finding ways to partner with the food science community to move nutrition and food science forward together. And as both speakers, I think, highlighted, there is certainly space for a bridge between the two fields. And I think many of us have been trying to work in this space for some time. As an early career scientist, Julie's interested in really finding ways of making this happen, because she says she doesn't feel she's seen many examples. Now, I think I'm going to let both speakers have a go at this one. Jaya, please, you start.
Yeah, Julie, very pleased to see your interest in matrimony between nutrition and food science. As a nutritionist, I would strongly recommend that you connect up with some universities in the UK that are in this space of interface. Leeds University has got a very strong department of food science along with nutrition. Leeds, Nottingham comes to mind, also Reading, certainly, where you are. Or if you are keen to come a bit further, you're most welcome to come to Singapore.
Okay, Peter, do you want to just comment on that? I'll come in.
Yeah, again, at Echo, there's a real interest in some of the sensory forums and conferences looking at that bridge. And you talked about sensors, Jaya, that in the UK, but there's also Wageningen University, which are really strong in this space. And I think this new UFIC project, this root reformulate project, I think it'd be worth trying to see if there are opportunities to get involved in that. I'm not sure what opportunities there are, but certainly reaching out to the researchers in that group would be really good. But I think the sensory community and the various kind of conferences and seminars, whether at a national level or international level, there's a real appetite, on the pun, for understanding kind of the link between nutrition and food science. And so I think I would really follow that route for sure.
Yeah, thank you, Peter and Jaya. And Julie, just from my perspective, the IFST in the UK and the IFT British section have both got an interest in bridging this, or forming a bridge between nutrition and food technology, food science. And in fact, the IFST has a specific group on food science and nutrition. And if you wish, we can certainly put you in touch with those people. But I think in the food technology community, there is a recognition of the driver of the importance of nutrition, health, public health, and so on. And certainly going forward, I think, as Jaya and Peter highlighted, there are big opportunities here for further collaboration. Okay, another question, Peter, probably to you, but maybe Jaya would like to comment. Has food texture and related eating rate modification findings been translated to lowering obesity at population level? In other words, how far has this gone?
Yeah, I think the reality is it's relatively early days. So a lot of the work's been done kind of through clinical trials. So this relationship, I think, is been established at a clinical trial level, maybe, but it hasn't really been applied in a kind of applied sense. So early days, I think, Colin, would be my comment on that. But it does suggest to me that there's real opportunity to take that research and start to take it forward in an applied way.
Jaya, do you want to comment on that?
Yeah, just to add to what Peter said, and I think the whole idea of fast and slow eating and the implications of fast eaters consuming more energy, I think is a well-documented observation. But the real challenge is, how do you translate that? And I think all the sensory scientists that I've spoken to acknowledge that translating the factual information that's observational is a big challenge, because trying to get people to eat slowly is not easy. But most of all, how do you maintain the slow retardation of consumption without, downrailing the gustatory attribute of eating? So I think Peter alluded to that, because it's a kind of a conflict of interest. Slow eating by tautology also may distort your pleasure. So I think there are so many questions that are there. But Peter is right. It's early days. Documented evidence substantially good that there is a link between eating rate and energy consumption. So I think we need to build on that in the not too distant future.
Good. Okay. Julie, I notice you've come back with a comment that you are based in the US. Can I therefore suggest that you might contact the IFT in Chicago? Because I know they are working closely with the American Society of Nutrition. So I think, the Professional Institute, both in the UK and in the US, and I'm sure other parts of the world, are very keen to form the bridge between nutrition and food science and technology. Okay, we have another question from one of our attendees. Do we have any data on the differences between populations from different countries as to their different eating habits? That's quite a fascinating question. while the speakers are thinking about it, I remember a conversation I had with a Japanese friend, and this was at a time when she was a child in Japan, and food was actually quite scarce, and her parents insisted she ate very, very slowly to extract the maximum nutrition from the small amount of food they had. So that's an interesting little anecdote, but I don't know, Jaya, whether you know of any differences in eating habits. You've worked in different parts of the world. You're on mute.
Yeah, sorry. So I think it's a very, very interesting and clever question. I think there are two levels of response to it. One is a more sort of granular response, which is that if you look at what I would call completely isolated food habits, it's quite hard to find them today, except in sort of isolated societies around the world. In other words, if you went to Japan now, Colin, taking your Japanese example, Japanese cuisine has got other cuisines also added to it, just as much as British cuisine now is much more broader than what the historical British cuisine is. So I think that's a real problem. But to answer your question in a much more broader sense, if you look at the eating habits of the Japanese, again, I'm using them more as a metaphor than anything else, look at the way in which they consume foods in small quantities in different varieties in a bento box. That's one example. Compare that with a South Indian diet where you eat large mountains of rice with small morsels of vegetables and what have you, and contrast that with a sandwich that we'd have in the Western world. So I think there are very, very varied dietary habits, but I don't think one has a clear substantial scientific evidence whether one is better than the other, because how do we do such experiments is a kind of an imponderable question that I have no clear answer to.
Peter, any comment?
Yeah, I think one of the interesting things, again, from my point of view, is not so much kind of multicultural differences, but actually differences in the way that people live and work together. So, for example, cities, I think, are very different. Probably there's more commonality between the folk in London, Paris, and Berlin in terms of their approach to their dietary habits than there are in the countryside in each of those respective countries. So there's another dimension which kind of cuts across, I think, sort of territory, if you like, to almost social and cultural aspects and the way that, as I say, people live and work. And I think that's a major impact in terms of people's dietary habits. But again, sorry, I don't have any more detail around the other aspects of that question, but that was my only additional comment on that.
Okay, thank you. Abigail has come back. What do you think the future applications of this interface between food science and nutrition are? What are the biggest issues that haven't yet been addressed? And maybe I'll just add something on to the end of that, because I think it's a fascinating question around, the move to plant proteins. Jay, you picked up on this, and also, I think most developed countries lack fiber in terms of their intake, yet we're moving towards greater refinement of plant material and so on. So, yeah, it's an interesting question, Abigail. Jaya, would you like to comment? You're muted.
Thanks, Colin. And I think you made a good sort of observation on those two elements. Abigail, I think there are three areas where the interface of food science and nutrition is going to really revolutionize public health. First is our understanding of enhancing bioavailability. Colin touched upon that. Isn't it a paradox that the more we make what we call, alternative protein-like foods, we are leaching all the micronutrients that we really ought to be having. The second point is that we simply do not know that the zinc and the copper and the iron and the calcium that we consume is completely unavailable. And I think ways of using food structural manipulation or food technology innovations to increase bioavailability will be a big revolutionary idea. The second area, I think, where there is much more opportunity on this interface is looking at ways in which you can alter food structure for sensory cues. Let me give you a good example. You probably have heard of this thing called microparticulated protein, right? Simplest. It used to be a product that was available many years ago. Basically, you take casein and you microparticulate it to 5 to 10, very, very small particles. And these proteins fail and look like lipids. So in other words, these proteins are now broken down into nanometer sizes, and therefore it gives the feeling of oil, but it's got no oil. So I think the nexus between food structure, nutritional paradigm, food structure and sensory, which is again what Peter touched upon, are two areas which I think are going to be hugely important, but these are just simple examples for much larger palette of opportunities that are going to be there in the not too distant future.
Okay, Peter, any additional comment?
Only additional comment, Colin, would be around the opportunity of taking kind of initiatives and innovation in food science, food technology, but taking consumers on that journey. So involving consumers and the various populations during that process, because I think we don't want to be in a position we've experienced in other times where we've kind of lost the engagement with consumers. So I think that's a critical other dimension to what Jay just highlighted in terms of the technical aspects.
Good, thank you. And now, Jay, one specifically for you from Catherine. Do the oleogels you mentioned perform the same in terms of mouthfeel and flavor release as conventional fat stroke oil?
Yeah, very good question, Catherine. The short answer is that in our food system, which was a rice porridge, there was no difference in using coconut oil as an oil or as an oleogel. But I think I cannot give you an answer for other food systems, for example, a chocolate or a souffle or creme brulee. But I'll be very surprised if there were any profoundly different organoleptic properties, because remember that the gel formation is at a physical chemical level, and when you process the food, it probably breaks down to look like microparticulated gels rather than microparticulated oil, if you see what I mean. So I hope I've given you half the answer. For our food system, which was a porridge, rice porridge, there was no difference.
And do you have any other examples where you've used that sort of approach, Jay?
Yes, we have also finished making some nice cookies, chocolate cookies, and chocolate chip-like cookies, and they also don't make any difference between. So I can give you a degree of assurance for the porridge and the chocolate cookies, it makes no difference. But I can't say if it's the same for cakes or for example, something like a donut or even something like a croissant. But I think it's a proof of concept. That's important.
Yeah, good. And Peter, maybe this is one for you. Back to Yang Yu again. Just really out of curiosity, has our food sensory system evolved or degraded compared to our ancestors in the context of evolution? Are there any research-based studies that might sort of...
I'm not off the top of my head. I don't think I can illuminate too much on that. It is an interesting question. I would have thought that, again, colleagues in Nottingham University might be able to help in some of those areas, but it's not something that I'm aware of in particular.
Okay.
Sorry, I couldn't expand on that. But,
No, okay, it's an intriguing question, I think. Yeah, okay. Well, I think we're approaching our finish time of 1:15 UK time. So I think I'm going to bring the session to a close by thanking all the attendees for tuning in today. It's been great to have such a good number of you attend throughout, and for your comments on the excellence of the two presentations. That's much appreciated. And of course, a special thank you to Jaya and Peter for their excellent presentations. I think we set out today to try and look at the breadth of science that's so important in the science of food and its application in a very small topic of really food structure, food texture. So, and clearly there's, I think, lots of potential, lots of opportunity for research, but I think should be lots of commercial interest as well. And I just encourage everybody attending to foster this relationship between food science, food technology, and nutrition. It wasn't so many years ago, Peter, was it, that century science was sort of on the edge of food technology and so on.
Mm-hmm.
In your early career,
Indeed,
and
yeah.
my early career, it was something that was a little bit of a challenge necessary to get included sometimes, but we've come a long way in the last 20 years on that. So hopefully we look forward to an exciting 20 years ahead in the food technology, nutrition interface, and to healthier foods for everyone. So thank you, everybody, and have a good day for the rest of the day.
Yeah, thanks again to Colin and the team of IFST and IFST. Really great program, and look forward to seeing you all again physically in the not too distant future. So many thanks from Singapore to everybody, and to Peter and Colin, and also all colleagues from IFST and IFT. Have a great day.
And
Likewise.
to Hannah and Danny behind the scenes for making the presentations run smoothly and the questions run hopefully smoothly as well. So thank you, everyone.
Thank you, Danny.
Bye now.
Thank you so much.
Bye.
Bye-bye.